In this clip, we're going to look at finding the domain of another rational function. It's just that this one we're going to have to do a little bit more work because we are protecting a denominator that contains a second degree expression. And so the values that would cause this denominator to be 0, thereby making the entire fraction undefined, are sort of hidden within that expression. But we can reveal those values by breaking this expression down into first degree factors. So the first thing I'm going to do is take the denominator, and I'm going to ask myself what would make that denominator 0. This is called finding the solutions, or also called finding the zeros of an equation. So in order to factor this, we're going to use what some refer to as the guess and check method. And that guess and check phrase comes from what you're going to do to find these back numbers. But to get the expressions that you're going to put in the first two positions, you're just breaking up the x squared. So it would be x times x. And then in order to fill out the back positions, it's kind of a two-step thought process. You're guessing at what are the numbers, just based on your knowledge of times tables, what are the numbers that multiply to give you -3, and in this case, super easy because that's a prime number. So 3 and 1. And then you're also trying to get the signs to be correct. So specifically, what numbers would multiply to give you -3, but also add to give you -2. So you're thinking of two things at one time. That would be -3 and +1. And check that, which is why it's called guess and check. You guess at the numbers that multiply to give you the constant, but then you check to see that they add up to be the middle term. This times this is -3, but when added, you get -2. So that checks out. Then as far as figuring out what makes this denominator 0, you can do that by looking at each of these factors separately, because any value that makes either this factor or this factor equal to 0 is going to make the entire expression equal to 0, and this factored expression represents the denominator. So the value that would make this factor equal to 0 would be x equal to -1. And therefore that value is non-allowable. You cannot input this value for x because it would cause a 0 here, make the whole fraction undefined. You also cannot use 3. So x equal to 3 is another non-allowable value. When you go to state the domain in interval notation, as MyLab Math is going to ask you for, it probably is best if you put these values on a number line. I'm sure some of you may be able to do it without thinking about the number line, and that's fine, but it typically helps people to get the interval notation correct. Put holes on the numbers, unshaded circles, put holes on the numbers of that cannot be used, and shade in all the numbers that can be used. You can use anything to the left of -1. You just can't use -1. So all the way out to -infinity is fine. You can use anything between -1 and 3. You just can't use 1 or 3. And you can use anything to the right of 3. So all the way to infinity. So then as you read this number line showing what you can and cannot use, you're able to complete your interval notation. Start on the left and move towards the right. That way you'll be stating the numbers smallest to largest. Okay, so it's everything from -infinity all the way up to, but not including -1, which is why we use a parenthesis. To jump over the value -1, we use the union symbol, which also means or. So this is read that the x values can be anything from -infinity to -1, non-inclusive of that -1, or it can be anything between -1 and 3, not including either one of those endpoints. Jump over the 3 using another union symbol, which means or it can be anything from 3 to +infinity. And that completes the domain for this rational expression. Remember, the only thing that causes a fraction to be undefined is zeros in the denominator, and that is why we are not addressing the expression that's in the numerator.